Hello, good evening. All right. Uh, so I am going to send a few links first before I start the class. So this is my Telegram group link. So this link it is free for all students. Right? You no need to pay one. Even now you are joining my tuition for free, right? But after that, after April, it is you need to pay. But if you join this group, it is free, right? But I don't send my link into here lah. So if next time you are not joining my tuition, you got question want to ask, you can ask there. I will answer you, right? If I can answer, then I will answer you lah, right? So you can ask question in this group by using English or BM or Mandarin. So I will answer you. The language that I can understand. Okay, so that is another link that I will send it to you also, which is this link. Now, if you need my notes, now some of you might don't have my notes yet. So you want to have my notes for free for chapter 1, 2. Now you can click this link to fill in the form. So after you fill in the form, you can read the term and condition there, and you don't need to pay anything. So I will send you the chapter 1 and then add you into the WhatsApp group. So for February and March, so the tuition fee will be eliminated, right? Totally free. You don't need to pay anything, including the material. Okay, now so okay, all right, and then before I start, I just tell you something that is important lah. So now this is my notes, right? This is my phone number, this is my notes. Now these notes here, you can download it and then you simply just click, like for example you want to do like how to derive the unit, you just click it, then it will go to page 15. You go to page 15 where page 15 how to derive the unit. So if you want to do like I want to do the step paper, so here, so now you just click it, then it will go to page 6. You can do the step paper there, so you can click it there. The next thing here, it is like now if you find it, the link that I send, right, like this. Okay, so this is, let's say you find it is not clear, it is blur here, let's say. When it is blur, so what you need to do is, now you can click here, the setting here, right? The setting here, so you can see the quality here. The quality got a few here. So I don't know what is your resolution of your computer. So you click there, so you adjust until the one that is this clearest for you. If not, you find it is blur. So, or I am using auto. So you check yours one. If yours one is blur, then you can find the best solution for you. So because of last year, got one student, she joined, then she totally cannot see anything because it is blur. So it is her computer's resolution problem. Okay. Now the next thing is, if you want to ask question, you can ask into the group. Into the chat box here. So you can tap in and ask question here. Or if you don't want, you PM me. Now if I don't answer you, you need to tell me again into the text, the chat box there, because I am not the screen that I see, it is my your text box. So if you want to WhatsApp me or Telegram me, all right, or Telegram in the group, right, you might tell me if I don't go and see it. All right. So basically this is what we have. Now next thing it is before this I need to introduce myself. I am Mr. Lee. You just call me Mr. Lee will be okay. So I'm teaching physics for 20 years, right? More than 20 years already. And okay, so this is what we have. Now this year this year I might need to teach faster because of the exam might be located maybe at December, right? SPM December. So from 4 I need to teach fast, from 5 also need to teach fast. Alright, so now if you want to join the Mandarin version, it will be Tuesday. Alright, so today, Wednesday one, it is English version, but the content will be the same. Okay, let's go for the tuition. Alright, so first of all, we are going to see what is measurement. So 1.1 physical quantity. What is physical quantity? Physical quantity. Physical quantity is something that you can measure, right? You can measure one, right? For example, length. For example, temperature. For example, time. You can measure how long time it takes. For example, mass, all this, right? So something that you can measure, right? Physical quantity is quantity that can be measured. So physical quantity can be divided into two types. So one type it is base quantity. Another one it is derived quantity. Okay. So what is base quantity? What is derived quantity? We are going to see. Base quantity. Base quantity is the quantity that cannot define in other term of physical quantity. Other physical quantity cannot. Right? Just itself. What does that mean? So now what does that mean? You better see what is derived quantity. After that we come back. Alright, so now we are having these 7 basic base quantity. You need to memorize or not? Yes, you need to memorize. It will ask in the objective in the SPM. So now you need to memorize the symbol, the base quantity, the symbol, and the unit also. Okay, so now length, the symbol it is L. Right, L. So the unit is M. Right, M is stand for meter. How many meter? Right, 20 meter, 30 meter. So now this mass also M, but this M is not meter. This M stand for mass. Right, this L stand for length. Right, mass. So the unit is kg, not gram. Kg. All right. Now temperature. Time, right? Current, right? Luminous intensity, amount of substance. So these 7, 1, 2, 3, 4, 5, 6, 7, you need to memorize, including the unit. Alright. So you see the time it is small t, the temperature it is big T. Right? Small t time, the unit is in second. Big T, it is in Kelvin, capital letter, K, big K. So, current is I, right? The unit is ampere, right? How many ampere? Right, 2 ampere, 15 ampere. The fuse that you use here is 13 ampere, right? That is the unit for the current, right? So, the next one is luminous intensity, LV, right? Luminous intensity. So the unit here it is CD, right? CD stands for candela. Candela. Right? How many candela? The light intensity. So the next one it is amount of substance, N, right? N. So the unit is mole. Right, how many mole? So mole stands for MOLE. Right, how many mole? Okay, so this is a 7 best quantity you need to memorize, right? Only best quantity, only this 7, right? Previously, the all syllabus one, it is just this 5. No, no 6, no 7. And then these two, even right now, we are not using in physics. Very, very seldom, right? Not using. Right? We only use these 5. 1, 2, 3, 4, 5. These two, no, right? Chemistry got amount of substance got. Luminous intensity, no, not at all. Okay. Now we quickly go to what is direct quantity first, and then after that we'll come back. So direct quantity is a physical quantity, not a best quantity. Other than this, it is direct quantity. So it is the quantity which derived from the best quantity through the multiplication or division. So you need to use the best quantity to make the physical quantity of direct quantity. You need to make the direct quantity, you need a best quantity by timing them or dividing them. Okay? Now, what does that mean? So, example, we are going to see later. So, we see this by here. Right? For example, area. Area. How to find the area? Area is, right? The symbol, it is A. Right? So, the formula is L square. So, now area is length multiplied by length. Okay, so length times length. So length, the unit is meter times meter. You look at the unit will be meter square. So this is best quantity. Length, it is best quantity. This one also best quantity, right? Best quantity. When best quantity multiplied by best quantity, it will become a derived quantity. So meaning that if you see a square, anything square, or m divided by s, or ms minus 1, or m kgm, mkg, whatever, time or divide, so it is derived quantity. How? What is derived quantity? Derived quantity is formed by the multiplication or division of the best quantity. Now, so for example, a speed is defined as rate of change of distance. Speed is equals to distance divided by time. Right? So distance, what is the unit of distance? Distance, the unit is in meter. The time, what is the unit of time? SI unit for time, second. Right? Meter divided by second. So we are going to write meter per second. So when you see meter per second, mean this one is divided by second. We call it per second. Okay, meter per second. You see the unit got combination of the best quantity already. So it is called direct quantity. So now you can see this density, velocity, acceleration, force, momentum, impulse, pressure, charge. All of these are called direct quantity. Okay? All of these are direct quantity. Now, the quantity that we are going to build the formula later during the exercise. Right? When we do the exercise, we are going to see how to make this direct quantity. Now, come back to what is best quantity. Now, what is best quantity? Best quantity is the quantity that cannot campur other quantity, cannot mix with other quantity, cannot define in other term of physical quantity. Length and length. You cannot length and mass. No, length and mass. Length divide by time. Cannot. So, if you divide, then it will be direct quantity. So, only length itself, only mass itself, it is called best quantity. Right? Only time itself, it is called best quantity. Alright? Is that okay for you? You need to memorize this. Okay. Now, after what is okay. So I need to ask you a very easy question, but it is kind of not very easy. Yeah. Now, okay. Let's say I got a physical quantity. It is called height. Right? Height. How high are you? The height of the object. How high? So this one is base or derived. What do you think? It is base quantity. Height. It is a base quantity or derived quantity. What do you think? It is not listed at here. It is not listed at here. Right? Height. Height. What do you think? What do you think? Come on. Let me know. Let me know your thought. What do you think? You can click the chat box there to answer my question. Yeah, YouTube will be delayed for like few seconds from what I say here. Delay like few seconds, but it is okay. Huh? You can answer me. All right. So if no answer, then I will answer myself. So height, the unit is how many meter, right? Right. How many meter? So this is base quantity, no other. So you tell me, teacher, meter isn't it length? Yes. Height, it is one kind of length. So we categorize height under length, like width under the length. Right? We don't call width or height already, so we just call length. Okay. So like for example, distance. Distance, we just put it as under length. So the distance unit is meter. So it is base quantity. Width, it is base quantity. The unit, you see the unit, then you will know. Base quantity or derived quantity. Okay. Now, what if what is speed? How fast you run? Speed. So the unit is like, for example, 10 meter per second. So you look at the meter per second. Oh, meter divided by second. So this is derived unit. You look at the unit, will be easy. Okay. All right. So base quantity and derived quantity. Now after that, we are going to categorize the quantity into vector quantity and scalar quantity. So what is scalar quantity? Scalar quantity are the physical quantity has a magnitude only, no direction. Only has magnitude but no direction. For example, you need to memorize distance, speed, time, temperature, area, volume, density, mass, work, or energy. All of these are no direction, only magnitude. So you will ask me, cikgu, apa itu magnitude? Okay, what is magnitude? Alright, for example, 5 seconds, the 5 is magnitude, the number. Magnitude is the number. Alright, for example, 20 kilometer. Right, so the 20 kilometer, it is 20, it is magnitude. Alright, okay, so now this one all don't have direction one, right? No direction. Okay. Now the vector quantity are the physical quantity has both magnitude and direction. Right? You need to know the definition. So this one has both magnitude and direction. Physical quantity has both magnitude and direction. So for example, displacement, velocity, acceleration, momentum, impulse, weight, force. Right? So this is the vector quantity. Vector quantity has direction one. So scalar quantity, no direction. Has magnitude only, no direction. Okay. Now, of course, teacher, I don't understand what is vector, what is scalar, what is distance, what is displacement. So I give you very, very easy example, right? But I will teach into detail chapter 2, all right? Here. For example, now I am working from here to here. I go from A to B and then I go to I turn back. I turn back. So I go from A to B and then I turn back to C. Right. So this one take me 20 meter. This one take me 5 meter. Okay. I turn back 5 meter. So now I am asking myself, right? So what is the distance that I have moved? Distance move is, so total distance move from A to B to C is 20 plus 5. So 20 plus 5. So answer is 25. 25 meter. Right? But what is displacement? What is displacement? Displacement is got direction. So distance displacement is vector quantity. It has direction. So now you need to know left and right. So go to the right, we said plus 20. So after that, it go to the left, you minus 5. So you just plus 20 minus 5, you get 15. So now the total displacement is 20 minus 5, which is 15 meter. 15 meter. So you can see the distance move and the displacement different. Why it is different? Because of displacement has direction. Displacement has direction. Distance no, just plus. Right? Just plus. Okay, I quickly take another example. For example, you move here, from here, you go 20 and then move 20 back and then move here 10. So here 20 meter, here 20 meter. So what is a distance? Distance normally I will use the unit of D lah, right? Big D. Total distance move is 20 plus 20 plus 10. So it is 50 meter. What is the total displacement move? Displacement, the symbol used is S. S, of course, you tell me, Cikgu, S is second. No, S is displacement. Symbol for displacement. Alright, so S is now here 20, here 20, here 10. So you tell me, Cikgu, this one is plus 20 minus 10. So plus 20 minus 20 minus 10. So it is negative 10 meter. Yeah. It is not 10. It is negative 10 because of this one got direction. The negative telling you the direction. The negative tell you where you are at the left hand side of the graph of the object of the origin. Right? The negative tell you left or right. So now this one is 25. I don't know where it is. I don't know. This one 50. I don't know where it is. But here, this one negative 10. Oh, I know it is this side. So where you start is here, right? So you are going to this side. So this one positive 15. Oh, I know you are going here, right hand side. So the distance and displacement. Displacement is vector because it has direction. It has direction. Okay, now I just briefly go through on here. So now what is velocity and speed first? Speed is no. Speed is equal to distance divided by time. We call it as rate of change in distance. Distance divided by time, rate of change in distance. I am not going to give you the definition right here. I just tell you how to calculate, right? Because chapter 2, I will reteach this one into detail, right? Now just briefly let you know. So this one is distance. This one is time, right? Distance, what is the unit? Distance unit is 20 meter, 30 meter, right? Time, it is in second. For example, this is 20. Okay, I put in 20 meter. So now in this process, probably I take 10 seconds. Let's say lah, I just take it as 10 seconds. So 20 meter divided by 10 seconds. So it is 2 meter per second. In this process, I'm taking 10 seconds. I said, now, distance divided by time. 20 meter divided by 10 seconds. So, 2 meter per second. The unit is meter per second. Alright. How about velocity? Velocity is rate of change in displacement. Displacement divided by time. Displacement divided by time. So what is displacement? How much is the displacement? Displacement is 15. Over the time, 10 seconds. 15 divided by 10, it is 1.5. Alright, 15 divided by 10, it is 1.5. You will see there is a difference between speed and velocity. Because speed, it is caused by the distance. And velocity is caused by the displacement. Okay? So when the displacement and distance, it is the same, then the speed and velocity will be the same. Okay? Now, of course, you ask me, Cikgu, this distance, it is base or derived? Base or derived? You look at the unit, it is base. Why? Meter. No meter square, not meter per second. No. Base quantity. So, it's vector or scalar. This is scalar. Scalar quantity. This one is scalar quantity. Now, this one is base or derived. You look at the unit, meter only. So, base quantity. But we are normally categorize it under length. Right? We don't use displacement or distance. But if you ask, then it will be base. Now, this one is vector quantity. Right? Vector quantity. Right? Displacement has direction, so it is vector. How about this one? Now this one is base or derived. Speed, it is base or derived. So answer is derived quantity because of meter per second already. You divide by second. Derived quantity. Alright. So this one, it is base or derived? Derived. This one is vector or scalar. So this one is scalar. This one is vector, right? I just explained to you. Okay, so this is what we have. Now, don't worry because of I just gave one example only. Now, in chapter 2, you are going to see into detail. What is linear motion? What is distance? What is displacement? How is it? How to calculate? How to calculate this? What is total distance? Total displacement? What is speed? Into detail. I will give you into detail. Not now. Now, what I gave you is you need to know. So when you need to know, I just agak-agak tell you. So you need to memorize it. So now you need to memorize this. After you understand, you don't need to memorize it already. So time. Where is the direction? No, time it is left or right. No. So time it is best. Sorry. It is best, yeah, correct. But it is scalar. Scalar, no direction. Best, we don't know whether it is got direction or no direction. Okay. So time, no direction, so it is scalar. So this one also best quantity. Right? Depend on how are you going to categorize it. Temperature. Temperature, you got -5 degrees Celsius, you got 20 degrees Celsius, 37 degrees Celsius, all this. So it is telling you a left or right. No, it is not telling you left or right. So this one is scalar. So area is left or right? No. Right? Volume, no. Density, no. Mass, no. But weight got direction. Weight is facing downward. Weight is the gravity acceleration act on it. So weight got direction. It is going downward. You need to know, Now, this one I want you to memorize very, very important here. This one, energy. You see, it is so great one, right? So normally, when I do velocity, right? What is velocity? Velocity is displacement divided by time, right? So displacement, because of displacement already vector. So this one is velocity is vector. Okay. Now force. Force is mass times acceleration. Mass, it is best. It is scalar. Right? So acceleration, it is here. Acceleration. Acceleration, it is derived. Derived not important here. I don't want to talk about derived. So it is vector. Okay. Scalar times vector, normally it is vector. Normally. Right? So this one is vector. So force, it is vector. Force and weight, it is vector. Vector quantity. Alright? Is that okay? But very weird one is this energy. Energy is the product of force and displacement. Force and displacement, you time it. Force, it is vector. Displacement, it is vector also. But vector times vector, then come out, it is not a vector, it is scalar. It is scalar. So this one I want you to memorize. It is scalar. Even it is vector times vector. But if you go others like vector times vector, normally it is vector. Normally. Right? Just this energy. It is scalar. You need to be very, very careful. Okay. Now, of course, you ask me, Cikgu, what is acceleration? So, like, I don't want to give you, but I tell you here, like, what is acceleration? Acceleration is you are going to learn in the future, and then you need to have a lot of calculation here. So now, what is acceleration? The formula is A is equal to velocity V minus U over T. V minus U over T. V is final velocity. U is initial velocity. Final, initial, over the time. Another word, this one is velocity divided by time. Velocity, the unit is ms minus 1. Divided by time. So the unit is ms negative 2. So when ms negative 2, obviously it is derived quantity. And this one got direction. So this one got direction. Why? Because of velocity got direction. So direction. So this one will be vector quantity. Okay. In chapter 2, we are going to go in detail. Chapter 1, I just need to have 2 weeks only. No need to worry. Very soon, next week. After next week, then we can go to chapter 2 already. Next week, I will teach you what is acceleration already. Okay. Now, a few things that I want to let you know, it is I see where it is. Imperial unit I need to find, right? Now, it is not in your textbook, but sometimes it come out in the exam. What is imperial unit? Okay, so I am going to Google for you, right? What is imperial unit? Okay, so Google said that imperial unit, it is the measurement to define a system of measuring quantity as length, as mass, as volume, as area, whatever. But it is best in UK, United Kingdom, England, right? England use one, not we use one, right? We don't use it. We use it, but very seldom. Now, for example, now, inch, right? So like you how high are you? So normally, if I ask you, how high are you? So you tell me 165 cm, or you tell me, Jegu, you don't tell me the unit cm also can. You tell me 1.65. Oh, I know you are mentioning 1.65 meter, but 1.65 meters is how many feet? 4 feet, 5 feet? I don't know. I don't use it because we seldom use it. But I can convert lah. I can convert, but we normally don't use it. Right? Like not like in England they are using 5 feet 4, 4 feet 2, 10 feet. They will measure in feet. Right? For weight they will call it as pound. How many pound? Right? Water, the volume they will use gallon. How many gallon? The weight they were going to use tons. Fruit ounce. All this. We don't use it. We use it SI unit. Right? This is called. All of these are called imperial unit. Imperial unit, which is England use one. Okay, so you need to know lah. So now we are going to do some question together. All right. Now here, from here. Now exercise. A physical quantity is something that can be measured. All right. Quantity cannot be derived. No, this is best. Quantity contain a magnetic and direction. No, this is vector. Quantity cannot be measured. Cannot be measured. Of course, you tell me, Cikgu, apa cannot be measured, huh? What is the thing that cannot be measured? For example, your dream cannot be measured, right? So now, this one, quantity can be measured. Yes, right. Quantity can be measured. Next one, which physical quantity is best quantity? Best quantity got 7, right? What is that 7? Okay, so we try to revise back, recall back. So we got length, we got mass, we got time, we got temperature, we got electric current, amount of substance, and number of mole. Amount of substance and luminous intensity. Sorry, the number of mole is amount of substance. Okay, so these 7 you need to memorize. Resistance, no, it is not here. Potential difference, it is not here. Electric current, yes. Electric current, yes. It is here. Electric power, no, not power. It is current, right? So now, my notes here. You go and find it. You need to memorize. That's why you need to memorize. So now, electric current, yes. Okay, it is here. Best quantity. So they ask me which one is best quantity. So current. I think this one is easy for you. So which one is not scalar? Not scalar. So I want to see which one is scalar first. Scalar means no direction. So weight got direction. Weight is going down. I told you weight it is going down. Now time don't have direction. Temperature no direction. Energy no direction. Alright, I told you energy don't have direction. Alright. So answer is A. A no direction. So this one is the not derived again. It is vector quantity. Number 4. So this unit is equivalent to Newton per meter square. So which one? So this one you are going to learn in Form 5, but I just want to let you know, right, how to derive the unit here. So now this one you will learn in Form 5. I show you. Form 5. Pressure. So what is pressure? Pressure is force over area. Force, the unit is pressure is equals to force over area. Force unit it is Newton. Area the unit is meter square. So the unit is Newton per meter square. So this Newton per meter square, this is a force pressure. So this force we got another name. So we don't name it Newton per meter square. We name under this person. Right? This person named Pascal. So we call it as PA. PA is the unit of Newton per meter square in Form 5. You are going to learn it. Pascal. Right? Pascal. Pascal. Huh? So the unit equivalent to Newton per meter square, I just show you, it is Pascal. Right? This guy's name. What? It is a guy name. So this one, it is the unit of power. Right? So Joule. Joule is the unit of energy. Right? And then Coulomb, it is the unit of charge. Yeah. For this one, the unit of power. Right? This one, the unit of energy. Joule. Joule, right? Energy. Lastly, charge, it is in Coulomb. Okay. Now, question number 5. Which of the physical quantity is correct SI unit? Alright. SI unit, I told you you need to memorize also. Right? Quantity of matter is amount of substance. Same thing. Right? So it is more correct. Temperature, it is not in degrees Celsius. It is in Kelvin. Big K. Capital letter K. Mass, it is in kg, not gram. Time, it is in second, not hour. So this one answer, it is A. Which is, you can find it from here. Right, the SI unit, the correct SI unit. The correct SI unit, the correct SI unit is here. Amount of substance, more. Okay. Now, density is the direct quantity. The quantity can be expressed as, so what is density? Density is equals to mass over volume. Okay. Density, the formula is mass over volume. So mass is unit of kg. Right. Volume is length time length time length. So this is mass. Right. M over L. M over L. Yeah. Answer is A. Okay. Answer is A. You need to know the formula. Of course, you ask me, Cikgu, the formula given or not in the exam? Not all. Density is not given. You need to know. Like, For example, the formula they are going to give in the exam is like this. They will give you according to the chapter, right? So this is the formula. What is momentum? What is force? Force is product of mass and A, acceleration. What is this? Acceleration, V minus U over T. All this they will give you. Okay, they will give you this, but density don't have. Don't have. They will give you all this. What is current? What is all this lah? They will give you. This is a formula list. Same question from here. I take it from here. Okay. Are you okay with here? I give you one very easy question to try. Which quantity is a vector quantity? A, B, C, D. So you try. You can vote it right here. Question number 7. Right. A, B, C, D. You can vote there. I cannot see who is voting, but I can see the number. How many number of you are voting? I cannot see who is voting. You just vote there. Which quantity is vector? Okay. Only one of you vote. But never mind. So, so what you vote is A. Okay. So which one is vector quantity? Vector quantity, acceleration, correct. Right? Because of acceleration has direction. Where? From my notes here. You can see from my notes here. Right? One of it is acceleration, vector quantity. Okay. So other than these are base quantity. For example, energy, mass, and distance. Okay, next one. Which of the following is this correct? Scalar and vector. So now scalar quantity, no direction. This one has direction one. Okay. Now momentum got direction or not? Yes, momentum got direction. So this one salah. Of course, you ask me, how do you know? So momentum is mass times velocity. Mass no direction, velocity got direction. So when no direction got time direction, so it is got direction. So this one is vector. So this one salah. So force got direction or not? Yes. Force is equals to mass times acceleration. You haven't learned it lah. This one you haven't learned it. You haven't learned. But I just tell you quickly. Mass no direction, acceleration got direction. So this one force is got direction. Force, you will tell me, where do you push the force? Push to the left or push to the right? Pull up or pull down? Force got direction. Right? So this one got direction. This one also got direction. Okay? I mean, this one got direction. This one got direction. So mass no direction. Mass is left or right? No, don't have. Right? But weight is going down. Right? Density no direction. Density is a scalar quantity. Time no direction. Time it is left or right? No. Okay? So displacement got direction? Yes, displacement got. I just show you displacement got. Can be left or right. So answer is Scalar, no direction. Vector, got direction. So answer is D. Excuse me. All right. Okay. I tell you what. Normally, I will like rest for 5 to 10 minutes the uh in between add something to 8:30 like that. Let you to go to rest for like a while, go to toilet for a while, go to drink water for a little while, uh, right, go to toilet for a while. So now here, if you don't want to go, now you can have to do the step paper. We are going to do the step paper later. Right, you want to do it, you can do it first. Right, from question number 1, page 6, until we are going to do until 11. 6 until 11. Okay, you can go to rest for a little while, and then yeah, don't forget, help me to press the like button. If you haven't subscribed to my channel, you can subscribe my channel, so you press the like button for me. Thank you. I'll be right back in 5 minute times. All right, I am back. Okay. So let's do the step paper together. This one. So electrical energy can be defined using the formula E is equals VIT, where E is electrical energy, V is potential difference, I is current, T is time. So which one it is true? Potential difference, it is a best quantity. So best quantity, that is 7 only. Alright. So what is that? Length, mass, time, temperature, current, luminous intensity, and amount of substance. Okay. So other than this, it is not best quantity. So this one is wrong. So electrical energy is scalar quantity. It is not scalar. It is scalar or not. Electrical energy, it is scalar quantity or not. Yeah, it is. Wait. No. It is electrical energy got direction one. You will flow to the left or right. Okay, so this one is wrong. It will flow into the circuit, you will flow in one direction or other direction. So it has direction one. So why it has direction? Because of the current, not because of time. So now time, it is a vector. No, time, it is not a vector. It is time, it is a not best. So time, it is a scalar quantity because time don't have direction. Right? Electrical energy is direct quantity. Yeah, when you multiply this one, and this one, so it is more than one. So it is a derived quantity. Yes. So answer is D. Answer is D. Yeah. Next one. Now, which of the following SI unit is correct? So mass, it is in gram. No, mass will be in kg. The SI unit, it is in kg. Time, the unit is in second. Yes, correct. So answer is B. We look at C. Length, the unit is in meter. Not cm. Temperature, the unit, it is in Kelvin. Capital letter. Kelvin. How many Kelvin? Okay. Now, next one. Which of the following is imperial unit? Imperial unit is inch. This is SI unit, meter. More, it is SI unit. Candela, it is a SI unit. Okay, so this one is imperial unit. What is imperial unit again? So the unit that we use in UK measuring system. Okay, so which of the following are all derived quantity? I want derived quantity only. So other than that, 7 will be derived quantity. False, correct. Time, no. Time, it is best. Momentum, yes. Force, yes. Velocity, yes. So answer is B. Length, no. Length, it is best quantity. Time, it is best quantity, no. So answer it is B. Now, which of the following is this derived quantity? Derived quantity. So, period. Period, it is time. Now, when we do normally we are going to use T time as small t. Right? Small t. I said small t. I still write big T. Okay, small t. But period is a kind of time. But we normally use it as big T, capital letter T, to differentiate it is T and T. Now, of course, you ask me, teacher, this big T, isn't it temperature? Yes, also temperature. So sometimes we don't use it, so we just write it as period. Period, it is time. So it is a best quantity. Time, it is best quantity. Now, this placement, it is in meter, the unit, right? So it is a best quantity. Force, yes, force. Force is the product of mass and acceleration. Okay, so this one is a direct quantity. So this one is best quantity, temperature. So answer is C. If any question that you want to ask, you can just leave it into the comment there. I will answer you. All right. Okay. Now, what is the diagram one show Ayuni stand at O. Then she works toward B. She go to B and then toward A again. She goes 7 and then 9. Okay? 7 and then 9. So what is the displacement of Ayuni? Ayuni is where you start to where you stop. You plus 7 minus 9. So answer supposed to be negative 2, but don't have negative 2. So we just take it as 2. Okay, so the correct answer is negative 2 meter. Should be negative 2 meter because of where you start to where you stop. Okay, this is displacement. If they ask you what is the distance, distance is 7 plus 9. 7 plus 9 distance. Okay. Now, next one. Which of the following is not a best quantity in SI unit system? Second, yes, best quantity. Candela, yes, best quantity. Centimeter, no. Meter, yes. Centimeter, no. So answer is C. More, yes. Now, next one. Which of the following it is a metric unit? Metric mean measure in length one. Inch, yes. Meter, yes. Ela is yard, yes. Feet, yes. Which of the following is the metric unit? Metric unit is in meter. Meter one. Okay, so answer is B. This one is imperial unit. This one is imperial unit. This one is imperial unit. So of course you ask me, teacher, what is yard? Yard, yard, it is like 12 yard penalty kick. That one 12 yard. 30 yard. So we don't use yard in our daily life. Right? Yard, it is like in Mandarin, this one is called ma. 12码12 yard meter inch 这个是寸 how to write 寸 yeah 寸 feet 尺 wait how to write 尺 okay how many feet okay metric unit it is B meter. Now, what is the imperial unit of pressure gauge? Imperial unit of pressure gauge is, now this one is out of your what you have learned right here. So the one that you are learned is, now here this is PSI, this is kilopascal, this one is Newton per meter square. This one is cmHg. All of these are measuring pressure. Right? All of these are measuring pressure. So the one that we use is kilopascal is same as kilopascal is same as Pascal. because of kilo only, right? Kilo. So like 20,000 Pascal, we are going to write it as 20 kilopascal. The Pascal is equivalent to Newton per meter square, right? How many Pascal is how many Newton per meter square. Okay, so these two, it is the same. Now this cm of mercury or another kind of measuring atmospheric pressure. So pressure gauge, you got another one, which is if you go to the Shell station or petrol station, you want to pump the air, you see PSI there. PSI is the unit of measuring there. So I'll show you. You'll learn in Form 5. Pressure. Pressure, atmospheric pressure, that you are going to use this Pascal, right, of cm of mercury, or how many atm, or how many meter. So the one that you see, you can see from here. I want to show you. See whether I got it or not. Don't have the picture of the pressure gauge. No, don't have. No, you cannot see. Too blur. Don't have. Right. Never mind. I show you by using here. Pressure gauge. Okay. This is the pressure gauge. So you can see this is the unit. All right. Pascal. This is PSI. Right. So they can use PSI to measure. PSI to measure. Right. PSI. Pressure gauge. Use PSI. Now, which of the following is a vector quantity? Now, time it is mass and scalar. So this one mass, no direction, scalar. Distance also no direction. So this one got direction. Displacement got left and right. So this one vector, yeah, displacement. This one PSI. So where I find here. So diagram 1 shows a pressure gauge. So unit of PSI is example of SI unit, metric unit, imperial unit. Imperial unit. Okay. So which pair it is correct? So now weight it is vector, weight it is going down. Yes. Alright, correct. Distance it is not a vector, it is scalar. Distance no direction. Velocity got direction, but speed don't have. So this one salah. Wrong. Acceleration it is got direction one. Okay. So answer is E. Inch is the example of SI unit, no. Metric unit, no. Chinese unit, no. Imperial unit, yeah. Imperial unit, inch. Right? How many inch? So we are going to do this structural equation right here. Now, diagram 1 shows a graph of displacement against time for two racing cars on a straight track. Initially, the racing car A is at starting line and racing car B is 15 meters ahead. Okay. Now, okay, I copy this one into here. Okay. Now, I got two cars. So, car A is starting point here. A. B. And it is like 50 meter. Alright, I draw further. 50 meter further. Car B is at here. So this one is 50 meter. So car A start from here. Ooh, they start together. Time start, they start together. Right? So now this one move from here to here. So move to 20 meter here. So another word, B is moving 5 meter only. B is moving 5 meter. B is moving from here. A is moving from here to here. Okay? A is moving from here to here. Okay? So at 10 seconds, where are A? A is at 20. A is at 20. A will reach here. B will reach here also. B will reach here also. Okay? This is the chat telling me. What is the chat telling me? Okay. Now, from here, so we are going to start to answer question. Tick the correct box. Correct answer in the box provided. Displacement is best or derived. So displacement is just meter. Displacement is just meter only. Right? Meter, it is best quantity. Now it is not categorized into the best quantity directly. It is under the length. Right? I told you before, length. Okay. Now, state what happened to the racing car A and B at the 10 second. At 10 second, what happened? What happened? So, the car A will collide the car B. Racing car A or you can use other way to answer. Racing car A will reach the destination of 20 meter, the displacement of 20 meter. B also will reach at the destination 20 meter. Alright, car A and B will reach the destination together. Okay, now calculate the velocity of car B. Alright, so velocity, how are we going to calculate? Velocity is equals to displacement divided by time. Right, displacement divided by time. So how much is the displacement that it moves? Right, so like what I told you just now is displacement is where you start to where you stop. Okay, so where you start to where you stop. 15 go to 20, so 20 minus 15. 20 minus 15, it is 5. Okay, 20 minus 15, it is 5 meter. Time, it is in 10 seconds. So answer 5 divided by 10, it is 0.5 meter per second. Okay, now because of you are new, so I need to tell you technique of answering first. Okay, that when you answer the question, I want you to write first one as formula. Second one is substitution. You substitute the value into it. Now, no meter, no unit, can or not can? Answer is can. Can. Substitution can. No unit, okay. No problem. But final answer, answer with unit. Unit at the last one, you must write your unit in. No unit, you write 0.5 only. 5 divided 10, 0.5. Salah. No unit, you short of 1 mark. Okay, the way to answer in the exam, be careful. Formula, substitution, and answer with correct unit. Okay, this is what we have. Right, so we go to see the answer. Sarawak paper. Wait. 2021. Wait. 2021. Yeah. Sarawak. Yeah, this question. The answer is here. Okay. So it is a best quantity. Best quantity, yeah, correct. Collide, number two, collide or same displacement from the starting line. Car A will collide to resin car B. Okay, no problem. Right? Or you can say same displacement. Right? Number three is 0.5. So now what is, teacher, this one got right gradient of the graph, right? Gradient of the graph. So we haven't learned what is gradient of graph. In next topic, then we are going to learn. So you need to write what is gradient of the graph, right? So now you substitute 20 minus 15 over 10. So you're supposed to write 20 minus 15, right? Don't just write 5. 20 minus 15, right? Right? How do you calculate, right? Over the time. So my one just now, it might give you wrong. You better be careful. Okay. Is there any question from here? I hope you are okay. Now, next one. Diagram 1.1 shows a mercury thermometer. Now, complete the sentence by ticking the correct box. So, the thermometer is used to measure the change in the temperature, not the heat. Okay? Change in the temperature. Change in the temperature. So, answer is here. Now, based on 1.2, now complete the following sentence underlining the correct facts in the bracket. Okay. Now, the thermometer with smaller bulb is more sensitive or less sensitive? Answer is less sensitive. Of course, I'll tell you why it is less sensitive, right? Than the thermometer with larger bulb. So of course, what is sensitive? Okay. So let me explain to you what is sensitive first. Now, I got two kind of, I don't want to use thermometer. I use other measuring instrument to explain to you what is sensitive. For example, I got two balance. One balance, it is look like this. Okay, you press a mango onto the balance, so it will show you 1 kg. Let's say 1 kg. Okay, so this one can measure how much is the size of the mango, what is the mass of the mango. Okay, so another one, it is the one that you are normally used in the supermarket. So it is electronic balance there. So now you press a mango onto it, so it will show you, this one is 1 kg. Okay, so both can measure, but which one is more sensitive? All right, so I remove the mango. So I put one piece of vegetable onto it. One piece of vegetable, very light. So now you find it, this one is like not really moving. So it moves a little bit. You cannot see the difference. So little. So this one will show you 0.01234. You show you, this one is 0.2 gram. So this one we call it as sensitive. This one very sensitive, very tune. Even little of piece of vegetable you put on top, also they will show you the change of the reading. Even very small also can detect. So mean it is more sensitive. Is that okay? So this one not so sensitive. This one is more sensitive. So which one is more sensitive? The bulb with the size larger bulb, it is more sensitive. Why? Okay. Now, this one you will learn in chapter 4. Okay. This one. Okay. How to calibrate the liquid in glass thermometer? By using the two fixed point. So this is called bulb. This is called bulb. Okay, inside there it is called capillary tube. Why you are using mercury? Because the mercury expands uniformly when heated. Because it is a good heat conductor. Because of it is opaque, low freezing point, high boiling point. So sometimes you are using alcohol for clinical thermometer. So now the one that I am going to see is the bulb size is small. So when the bulb size it is small, the size of the bulb it is small. When the size of the bulb it is small, then it will be less mercury in it, so it can absorb more quickly. Oh, okay, it should be small. So bulb small, it is more. It can absorb more quickly. Not big. I'm sorry. So the bulb have to be small bulb. These bulb have to be small bulb. Right? We see here. Wait. So this one it is small. This one it is big. So when the 1.2, right, smaller bulb more sensitive. Okay, I'm sorry. Here should be more sensitive. Wait. Small bulb is more sensitive. Big bulb is not that sensitive, right? Because of when small bulb, it can absorb the heat more fast, right? More easy to absorb heat. Okay. Now answer is more sensitive, smaller bulb. Okay. Now state the physical change in the mercury when the temperature increase, right? When the temperature increase, what happened to this one? This one will expand. So the mercury will expand. So they will ask you what happened to the mercury. The mercury will expand. Mean the volume of the mercury will increase. Volume of the mercury will increase. Will expand. Also can. Volume increase also can. Same. Right? Give one reason why the mercury is used in the thermometer. So why mercury is used? Many reasons. Right? One of the reason is expand uniformly when heated. Or you can say it is a good heat conductor, right? Or you can say it is a good heat conductor. Simply take one only. Just say one, right? Or you can say it is opaque. Because of it is opaque. Right, just now here. So why it is used? Expand uniformly when heated. Good heat conductor. Opaque. High boiling point, low freezing point, all can. Why? From chapter 4, I will explain in detail to you. Right, we go to see the answer very, very quickly. Melaka 2020. Melaka. Question number 1. So the change in the temperature of the object. Change the temperature of the object. Right? Wait, I cross down this one first. Okay. Change the temperature of the object. Now, more sensitive is here. More sensitive. Yeah, more sensitive. Now, next one. See, the expansion of the mercury or increase of the volume of the mercury. Volume will be increased, yeah? Increase the volume of the mercury, yeah. Next one. Does not stick to the wall, not vaporize, opaque, easy to see, good conductor. So this good conductor, not good, right? I don't want you to write good conductor. I want you to write good heat conductor, because conductor is conduct electricity. So don't write this, right? Don't use good conductor. Use good heat conductor. High boiling point, not stick to the glass. All can, right? So you just simply take one. The one that I prefer is expand uniformly when heated, but it is not in the answer scheme. Right? Good heat conductor, yeah. Opaque, yeah. Either one. Right? Either one of these three will be okay. No problem. Okay. If you got question, please ask me. Yeah. Now, Johor 2021, we are going to see diagram 1 shows the consumer need to undergo the body temperature to check before entering the business premises when COVID-19 outbreak strikes. So complete the following sentence by tick the correct definition. Temperature is degree of hotness. Degree of hotness. Temperature is degree of hotness. So what is a form of energy? Heat. Heat is a form of energy. Where it is just yeah, I should not cross down just now. But never mind. Where is this? Whatever lah. Here. Here. Heat is a energy content in the object. Temperature is degree of hotness. So chapter 4 we are going to learn it. Okay. So temperature is degree of hotness. What is form of energy? Heat. So temperature is not heat. Temperature and heat are two different things. So answer is this. Okay. Next. Name the type of the physical quantity measured by the thermometer. So most of you will answer, temperature. Wrong. So why wrong? They said type. So type got two types. One, it is base derived, or base or derived, or vector and scalar. Either one. So I put it as base. I put it base. Base or derived. Right? This one is Kelvin, right? So this one is base. Base quantity. Set the unit represent the diagram 1. So diagram 1 is 36.6. The unit, set the unit, 30. Yeah. Diagram 1 is 36.6 degrees Celsius. Right? The one that 36.6 is degrees Celsius, not Kelvin, not Fahrenheit. No. So we are using degrees Celsius. What is the temperature reading from the diagram 1 in SI? Now you need to change to SI. So when you want to change to SI unit, okay, now if you got degrees Celsius, you want to change it, convert it to Kelvin, right? So you need to plus 273. If you got Kelvin, your answer is in Kelvin, you want to convert it to degrees Celsius, right? You need to minus 273 degrees Celsius. Okay, so what is this? This negative 273, it is called absolute zero. This one, negative 273, it is called absolute zero. Meaning that at that temperature, all the particles are freezing. So all the particles will not move at that temperature. Right? So how to change from 36.6 to Kelvin? So answer is 36.6 plus 273. So it is 300 and 319. Wait, cannot see. 36.6 plus 273. Okay, 6. This is 9. This is 0. 309. 309.6. Kelvin. Capital letter. Remember, it is capital letter. Okay. Now, yeah. Before that, I need to tell you, you need to prepare a calculator, scientific calculator. Probably you have it already lah. So I'm using this kind of calculator. So in the future, I'll teach you how to press a lot of things that you need to learn. So this one 309.6 Kelvin. Okay. Excuse me. We try to look at the answer. (2021) Johor. Johor, kertas 2 jawapan. Question number 1. Okay. Now, it is a degree of hotness. Okay. So, degree Celsius, you can write degree Celsius or degree Celsius like that. 309.6, yeah. No problem. Okay. State the unit. Ayo. Not write the value. State the unit. I'm sorry here. My mistake. I am wrong here. State the unit. Unit is degree Celsius. Degree Celsius. Degree Celsius, the unit. Okay? Or you can write degree Celsius like that. You can write this. Okay? You saw the answer just now, right? Okay. Now, next part, right? We are going to see how to derive the unit. This is a formula we'll give in the SPM, right? I combine all together here. Now, here. So how to derive the unit? So I do it very, very quickly. If I cannot finish, I leave some for you to do it on your own. Okay? All right. Before this, help me to press the like button there. Thank you very much. Your like, for me, it is very important. Every time you join, you help me to press the like button. Okay. Now we are going to do question A. So, how to find the area? How to derive the unit of area? Area is length times length. Length multiplied by length. So, length, what is the unit of length? Length, it is in meter. SI unit must be SI unit. So, time SI unit. So, meter times meter. So, what is the unit that we got? So, unit is meter square. So, the unit here, area, for area, so the unit will be length times length. So, the unit will meter times meter. So, it is meter square. Alright? So, B. Now, how to derive the volume? Alright? Volume is capital letter, volume. The symbol that we use is normally V lah, big B. Right? Big capital letter. Small one is velocity. Right? Volume is what times what? So it is area times height. Right? The area at the bottom times how high it is. Volume. Area, we got it already. Area, we got it already from here. Meter square. time height. Height, it is length, it is height. Height, it is length. So, time meter again. Sorry, this one is meter too. Right, meter square time meter. So, now, this is 1, this is 2, 1, this is 2. You time, you plus it. So, 1 plus 2, it is 3. So, meter time meter time meter. So, answer is meter cube. So, answer it is meter cube. The unit for volume, it is meter cube. Okay, we look at C. C, velocity. So velocity, you need to know the formula of velocity. Velocity V is equals to displacement divided by time. Displacement divided by time. So how to derive the unit? So displacement, we know the displacement just now already. It is in meter. It is in meter. Time, it is in second. So meter divided by second. When you divide by second, divide by anything, so you just minus 1. The unit is minus 1. So this one is meter per second. ms minus 1. Divide by second, minus 1. If divide by m divide by s square, so it is meter per second per second. But I will normally call it as meter per ms negative 2. I'll call it this way faster. So the correct way to pronounce it is meter per second per second. Okay. Alright, velocity, the unit, derive the unit, ms minus 1. D, acceleration. So acceleration, teacher, I don't know how to do the acceleration. A, the formula is given. Acceleration is equals to v minus u over t. The formula, it is given at here. Given in the exam. Here don't have. You will learn it. But just now, you will see it here. Wait. Never mind. I don't want to open. So the formula is A is equal to V minus U over T. V is velocity. U is initial velocity. Never mind. I open. Don't be lazy. Okay. Form 4. Form 4. Chapter 2. Okay. Linear motion. Yeah. A is equal to V minus U over T, where A is acceleration, the unit is ms negative 2. Final velocity, V is final velocity, ms minus 1. Initial velocity, ms minus 1. Velocity, minus 1. Right? So this is T is second. V minus U over T. This is a formula. So now here, acceleration is V minus U over T. V, what is the unit of V? V is final velocity. This one is initial velocity. The unit is ms minus 1. This one ms minus 1. When you minus, there is no change of unit. Like, why, teacher? Minus 1. 10 ms minus 1 minus 2 ms minus 1 is at ms minus 1. No change. Not like 10 ms minus 1 minus 2 ms minus 1 is 8. No. This one, no. Like RM10 minus RM2 left RM8. You minus. Minus, the unit will not change. That unit will remain. Okay? You got 10 ringgit minus 2 ringgit. You still got 8 ringgit. Not you still got 8. No, wrong. Okay? So the unit remain after you minus or plus, unless you divide and time. So now how are we going to change the unit here? So now A is equals to V minus U over T, right? V minus U over T, the unit is here. The unit is ms minus 1. Ms negative 1. Time, it is in second. So when ms minus 1, ms negative 2. So the unit of acceleration is ms negative 2. So the unit is ms negative 2. Is that okay? Ms negative minus 1 minus 1. Right? So minus 2. Acceleration, so E. Force. Force, normally we are going to use F. The formula is MA. This one, it is given here. F, this F, it is gravitational force. Right? We are going to use this one, easiest one. So this one is universal gravitational force. Right? This one is centripetal force. So these forces are the same. But we are going to use this one, the easiest one. MA. The easiest one. M we got right. M is mass. What is the unit of mass? What is the unit of mass? Mass is in kg. A, acceleration. Acceleration, you just find it. Right? The unit is ms negative 2. So the unit will be kg ms negative 2. But in daily life, we are seldom using kg ms negative 2. Kg ms negative 2 is SI unit, yes. But we normally use unit of F is Newton. So we use Newton. Newton is not SI unit. Right? We will use Newton. But Newton is representing kg ms negative 2. Because of kg ms negative 2 so long. So they use the unit of Newton. Like, for example, you go use the spring balance. You go measure this one. Okay. You tell me, oh, this one 10 Newton. Yeah, 10 Newton. So you will not say 10 kg meter per second. So long. You will not use that long. You will just say 10 Newton. This one 10 Newton. But 10 Newton, you need to memorize. Newton is not a SI unit. It is a combination of all of the unit to form a unit of Newton. Okay? Normally, use the unit of the force is Newton. Wait, I need to modify it. Normally use unit of N. Newton. Okay, E done. E. So F is momentum. Momentum, the symbol is P, but we very, very seldom use P because P can stand for pressure, can many other. So you see many P here. So momentum, normally in the exam, they also momentum, they'll just write momentum. Momentum is product of mass and velocity. Momentum is M times B. Okay, so we are going to put F. F is momentum. Is M times V. Right? M we got how much? Kg. Velocity we got how much? Ms negative 1. So ms negative 1. So the unit of momentum is kg ms negative 1. And because of this v velocity, it is a vector. Vector. Right? It has direction. So momentum m kg ms negative 1. So from here, you got a lot of the unit that you have derived. So you can try. I want you to try letter G. G first. Let me do G first. G is density. The symbol is rho. This one is called rho, density. Density, the formula is mass over volume. The volume is big V, not small v. Small v is velocity. Big V is volume. Okay? Big V is volume. So, density is equal to mass over volume. So, where... what am I doing? Mass over volume. Mass, what is the unit of mass? You know, right? In kg, right? Volume, volume here is meter cube. Meter cube. So, kg divided by meter cube. How are we going to write it? So, we are going to write it as kg per meter cube, per meter cube, per meter cube. Sorry. So, we are going to write kg m. So, bottom, this bottom, so we just minus. So, this one is 3, so just 3. Kg m minus 3. Kg m negative 3. So, how to pronounce this one? This one is supposed to be kilo per meter, per meter, per meter. But, I don't call it that way. I'll call it kg per meter cube. Okay? So, is that okay for you? Okay, now H and I and J, I will want you to do, right? So I want you to do H, I, and J. I give you some clue first. What is H? H, so H is what is H again? Pressure, right? Pressure, energy, power. Okay, pressure. So pressure, the formula is force over area. Got? Pressure. Density got a mass over volume here. I didn't find it. So, never mind. Don't have. So, pressure here. Pressure is equals to force over area. Force over area. So, force, you got the unit of force, right? Force under here is MA. M is kg. A is ms negative 2. Area is meter square. So when you see this one is divide, divide you can cancel one. Right? This one is supposed to be kg m s negative 2 divided by m times m. So you cancel one. Bottom still got 1, right? Bottom still got 1. So how are you to write it? How are you going to write it? Kg what? And then what? So normally they will form I don't want to tell you the answer. You try to do it and send it to me later. This is your homework. H, I, and J. You do it on your own. Energy. Energy, the formula is force times displacement. Force times displacement. Force you got, right? Force here. You put it in. And then S, what is the unit? You put it in. You time it. And then you got the answer. You do it on your own. This is your homework. And power. Lastly, power. Power is energy divided by time. So the energy, you got it here. You put it into here. And then time, what is the unit? Sorry. I wrote it accidentally. You put it in. Then you will get the answer. Alright? You do it and then send it to me. You know my number, right? You know my number. So you can send it to me, my number. Any other question? Next week, we are going to start to do a little bit of this one. This one is not in your textbook, but I think it is important for you to know. Uh, uh, next time, this one will be important for you. So next week we are going to do this one, and then we are going to finish this one next week. Right? We are going to finish this chapter next week. Any question before I end the class? Any question before I end the class? Now, before I end the class, I need to let you know. Now, you have filled in the form already so that you in my group, right? So I want you to let you know, February no need to pay, March also no need to pay, right? After March you need to pay monthly tuition fee RM 65 only per month. If you got friend want to join, you forward this video to them, you forward the Google form to them, ask them to join, right? If they join under your name, right, the referral there, they fill in your name. So every month, you will minus 10 ringgit. After April, if they join after April, they still stay, because February and March no tuition fee, so not rebate for you. No, you no need to pay. Even who join also no need to pay. But if after that one, after March, April, your tuition fee is 65, you got one friend join, you will need to pay 55 only. So ask your friend faster to join, right? Last year got one student, she invite 7, so she no need to pay any tuition fee. We need to, PTSC need to pay her every month. If got 2 students join under your name, so minus 20, you 35, right? Sorry, 20 or 45. 3, then 35. So see how many students join. If you got 7 students join, 65, minus 70 every month. So you got every month you got extra income from the tuition. Even you join the tuition, you don't need to pay, but you still get money. All right. So ask your friend to join. The Google form is at the top of here, right? The Google form. Ask them to fill in, right? On this one, term and condition, if they stay after what's that called? April, they also stay, right? They join 2 months and then they join February and March, they get the free one and then they quit, then no lah. Okay? Understand? If understand, then I am going to stop here earlier. You go to do the question H, I, and J and send it to me after this. Okay? I'm going to stop here. I am Mr. Lee, right? Ask your friend to join, invite your friend to join. You can send the Google form, you can send my video to them, because the video right now, it is open to public one. But after this, it is not open to public one. Okay? So I am going to stop here. I'll see you next week. Okay? Bye-bye. See you. Bye-bye.